Hello, everyone. Welcome back to SAT Math Question of the Day. We will do a Math SAT question a little bit later, but first in a separate video. Yesterday, we came up with a question that bothered Seth, that Seth had to do more thinking on. This is what you do when you have questions that you get wrong. Yesterday's video, May 18th, we got the question right, but we did it wrong. We did not do it correctly. This bothered Seth. So
what we did was we made an assumption without justifying it. We didn't think of checking whether this assumption was true. And then, following the assumption, we proposed an answer. And it turned out, even though we didn't think and test whether or not this assumption was true, in the problem we were faced, it was true. And so we got the answer right. However, if we applied the same method to a different problem where the assumption wouldn't be true, we would have gotten it wrong. So I'm going to show you how to deal with the kind of problem we faced. So here it is. I'll start by giving you the particular problem that we worked on. The question, we were given an equation. Okay, do you see it?
It says I only see y.
Okay, good. That's good enough. Y. I'm going to write this expression. Y minus the square root of 7y minus 31 equals 3. So this is an equation, and I'm not even going to tell you what the question about this equation was, but the problem type is to figure out what the roots of this equation are. Okay?
Yeah.
Now, this equation has a certain form. Well, so let me move it around and show you what it's like. Let me move the y. Let me isolate the radical. So what I'll do is, subtract y from both sides to move the y on the side with the 3. Right, and then all right, that doesn't matter. Let's put the radical. Let's put the radical with a plus sign. So multiply both sides by minus 1. And we've transformed the equation into the equation that asks us to assert that the square root of 7y minus 31.
Y minus 3.
Okay. Made it. Yeah, the usual thing.
That's why it's good to do math as a team.
Yeah.
One checks the other.
Yeah. Equals. What is it? Y minus 3.
Minus 3.
Okay. Now the general form of this.
That's supposed to be an equal sign, not a minus sign.
Yeah. So. Okay, we stable. So here we go. Here's the idea. The form of this equation is that we have two functions of y. Let's call them fun1. Fun1 function of y equals 7y minus 31. And fun2 of y.
I wonder whether you should change those to x's.
Okay. Now, here we go. I will refuse to let you interrupt me. Let's graph these two functions. So let's draw some axes. And do you see the lines?
Yes.
I don't. So let's wait for the internet to
So I was just going to suggest,
play the lines for me.
not a big interruption. Why don't you
This
change
is the
those to functions of
y-axis,
x's?
and this is the fun axis. The fun 1 and the fun 2. Okay, now 7y minus 31 is a well, let's plot it. When y equals 0, we have the value of the function is about minus 31, and it has a slope of 7. So it goes like that, right?
What? It's
right.
minus 31. Wait. Minus 30. Minus 31. The y-intercept is a minus 31, not a plus 31.
Yeah, sure. When y is 0, the value of fun 1 is minus 31.
Yeah, but you have it as plus 31, the way you drew it.
No, I didn't.
Where's the y? Where's the fun 1, fun 2 axis?
The y, this is the positive side of the y-axis.
Why don't you make those x's? Why don't you make those as functions of x's so everyone understands what's going on?
All right, yeah. I'm getting this all mixed up.
Make it functions of x's. Come on.
No. I don't want to make x's. Okay, here we are. I made a dumb mistake here. When y is 0, we're talking about this line, right? Y equals 0. So y is 0. The value of the function is negative 31, and it has a slope. It's very, very slopey. Right?
Very right.
Now, but what's on the equation is the square root of this. So what's on the left-hand side of the equation is the square root of fun 1 of y. Okay? So, however, the value of the square root doesn't exist in SAT math when the square root is applied to a negative number. Here, fun 1 is negative. Here, it's positive. And so if we now plot square roots in red, what you're going to get is a function that looks something like this. It's a parabola, but when you get to the y value that makes 7y minus 31 be negative, you can't, you don't draw it, right?
Right.
And then in SAT math, this symbol means positive square root. So we only draw the positive branch of the square root function. Now, let us now plot y minus 3. Y minus 3, let's see, when y is 0, fun 2 is minus 3, and the slope is 1. And what we therefore get is a straight line.
Seth, stop it.
Now, what is okay, you tell me, where can you find the solution to this problem?
Okay, first of all, Seth,
you think you're so smart. Tell me in this diagram where you can read off the solution to this problem.
First of all, Seth, I don't think I'm so smart. Okay, actually, I do not.
Okay, so shut up. Let me tell our audience.
Seth,
the solution to this problem.
Seth, stop. Time out.
Is where these points, where these two lines, where the parabola and the straight line have a point in common. And so in this case, this problem has two solutions. Now, what if instead of y minus 3, we had maybe y plus 17? Then the straight line would go like this, or the straight line would be way up here. And it would not cross the parabola. There'd be 0 solutions. And finally, what if the line went something like this? It cut down like this.
Then you'd have one solution.
Right? then it would hit the parabola somewhere here, but there's no bottom half because we're only taking positive square roots. So if the line were going down and down with a slope and hit it only here, there'd be only one solution.
Wow.
And so depending on what fun 1 and fun 2 is, there might be 2 solutions or 1 solution or 0 solutions, depending on how these two, how the half parabola and the straight line, how and how many times they intersect. And there's also the case where the straight line would be tangent to the parabola, in which case there'd be a single solution, but it would be a double solution. Okay, case rest.
Well, first of all, there's some insights here. Seth, that was absolutely brilliant. Wow, that was amazing. The other insight is that you didn't come up with it immediately. You had to take a walk. You had to think about this. And that's a big lesson. People who come up with such amazing things and understand things so well don't do it like this. Like you must have spent a decent amount of time thinking this through. Maybe taking a break, right? So,
yeah, well, I didn't think about it for maybe half a day, and I went. Well, yeah, we did it in the morning. I didn't think about it. I actually see what happened to my head. It was after I went to the barber.
Oh.
I got my hair cut.
Right.
And I was walking home, and I thought, oh, yeah, okay, that explains the whole problem.
Wow, and this is really interesting because it uses the graphical modality, which we always talk about in the SAT. Got to be ready to use the table for a function. A table, a graph, and algebra. And Seth combined a little bit of algebra, but mostly the graphical solution to show the conditions where radical equations can have one solution, no solutions, or like one extraneous solution, 2 extraneous solutions, or no extraneous solutions. Wow, that is amazing, Seth. That is really smart. I mean, insights, great. Wow. Only just 2 incredibly minor things which actually do not change your solution at all, but should be mentioned is 1, you did not draw a function here. This does not pass the vertical line test. See, you went like that. It really looks like that. Okay, the square root function.
Yeah.
That's a minor detail, but we should make that.
That's because of a poor coordination with my tablet.
And the other thing that's incredibly minor is you made the same mistake twice. Small mistake. Y minus 3. This is where it goes through. Not here. Okay, you made the same mistake. It goes this way. See, you put it on the wrong axis, the -3. The -3 really belongs here. Just so we don't want to. Don't you agree, Seth?
Yeah. Okay. So
you agree, right? I want to make sure people.
Yeah, I agree.
Yeah. Okay. Again, a minor mistake, but it doesn't change.
The trouble is, I was trying to do it before you interrupted me. Too fast.
Okay. Whatever.
I'm blaming it on you.
That's fine. You could blame it on me. It's fine. But it's all drawn completely out of scale. This shows that there's only one solution, but it's not true. This equation actually had 2 solutions. So, that's because it's over here. I drew it wrong. This was the axis. Right? Yeah. This was the axis that Seth was doing. Right. This is the function axis. So it actually goes like that. There are 2 solutions. Wow. Again, it doesn't take away from anything. Whoa, Seth, that was really smart. Okay, enough giving Seth the appreciation he deserves. That was great. I hope people see that. I've never seen it explained like that, and I hope people got something out of this. What a treat. My God. Whoa, that was really great. You must have felt good after thinking that through.
Yeah.
It's a good feeling when you have an insight that you've never seen before. Wow. Okay, so we're done, right? Yeah, we're done. Okay, so now we are going to still do SAT math question of the day for Friday, May 19th. This was just a discussion about yesterday. Okay, we will start up again for an official SAT math question of the day in a moment.